Welcome everybody. Today we are talking about YARN. YARN stands for Yet Another Resource Negotiator. It was introduced in Hadoop 2.0 to remove the bottleneck on job tracker which was present in Hadoop 1. YARN was described as Designed Resource Manager at the time of its launch, but it has now evolved to be known as Large-Scale Distributed Operating System used for big data processing. YARN architecture basically separates resource management layer from the processing layer in Hadoop 1 version. The responsibility of a job tracker is split between the resource manager and the application manager. YARN also allows different data processing engines like graph processing, interactive processing, stream processing, as well as batch processing to run and process data stored in HDFS, thus making the system much more efficient. Through its various content, it can dynamically allocate various resources and schedule the application processing for large volume data processing. It is quite necessary to manage the available resources properly so that every application can leverage them. YARN features. YARN gained popularity because of the following feature. Scalability. The schedule and resource manager of YARN architecture allows Hadoop manage thousands of nodes and clusters. Compatibility. YARN supports the existing MapReduce application without distribution thus making it compatible with Hadoop 1 as well. Cluster utilization. Since YARN supports dynamic utilization of cluster in Hadoop which enable optimized cluster utilization. Multi-tenancy. It allows multiple engine access, thus giving organization and benefit of multi-tenancy. Hadoop YARN architecture. The main content of YARN architecture includes client. It submits MapReduce job. Resource manager. It is the master daemon of YARN and it is responsible for resource assignment and management among the application. Whenever it receives a processing request, it forwards it to the corresponding node manager and allocate resources for the compilation of the request accordingly. It has two major content, scheduler and application manager. The scheduler. It performs scheduling based on the allocated application and available resources. It is a pure scheduler, meaning it does not perform other tasks such as monitoring or tracking and does not guarantee a restart if a task fails. The YARN scheduler supports plugins such as Capacity Scheduler and Fair Scheduler to partition the cluster resource. The application manager. It is responsible for accepting the application and negotiating the first container from the resource manager. It also restarts in application manager container if the task fails. The node manager. It takes care of individual node on Hadoop cluster and manages application and workflow and that particular node. Its primary job to keep up with the node manager. It monitors resource usage, performs log management and also kills a container based on directions from the resource manager. It is also responsible for creating container, process and start it on the request of application master. The application master. An application is a single job submitted to a framework. The application manager is responsible for negotiating resources with the resource manager, tracking the status and monitoring progress of a single application. The application master requests the container from the node manager by sending a container launch contest, which includes everything an application needs to run. Once the application is started, it sends the health report to the resource manager for time to time. The container. It is a collection of physical resources such as RAM, CPU, cores, and disks on a single node. The containers are invoked by container launch context, which is a record that contains information such as environment variables, security tokens, dependency, etc. Application workflow in Hadoop YARN. 1. Client submits an application. 2. The resource manager allocates a container to start the application manager. 3. Application manager registers itself with the resource manager. 4. The application manager negotiate container from the resource manager. 5. The application manager notify the node manager at launch containers. 6. Application code is executed in the container. 7. Client contacts resource manager, application manager to monitor application status. 8. Once the processing is complete, the application manager run and register with the resource manager. And as always, thanks for watching.